Thank you, Tanisha. Thank you so much for a very nice introduction. Good morning, everyone. I hope most of you are still in beds, or maybe you have just got up, or you're grabbing a cup of coffee. I promise I won't make you asleep. So yeah, let's start. So I'm Kamlesh. I work as I work at Razorpay on the platforms team, specifically working on design systems and dev tools. So, what is token? Huh? It's a thing of Web3. It's a token for building design system on blockchain, which means all of us are gonna get uh, rich. That's just a joke. So, design tokens are spicy variables. Let me elaborate what does spicy mean over here. So they are basically variables that can point to either another variables, or they could directly point to a hard-coded value. So just for an instance, let's say you have a variable called Azure.500 that might directly point to a hex value. Similarly, you might have a variable which is button background primary that might point to Azure 500 internally, and that points to another hex value. And similarly, let's say you have a border radius small that might directly point to 2 pixel, which says give me like the border radius of this particular element would be 2 pixel. So design tokens are basically design decisions, and they are kind of stored centrally. You don't like the consumption of it on different platforms. Let's say iOS, or let's say Android or web could be different. For example, box shadow. So to implement box shadow on iOS native or Android or web, it is kind of different, but still your decision remains the same, that you need a shadow of a particular with a particular elevation, right? And that's exactly what your design tokens talk about. Now let's see some benefits of design tokens. So imagine we create a alert and a badge component, and we say that we want to point to a background color of these components. They both are same, and you can see they both are pointing to a specific hex value. Now imagine that we want to change the background color of these components, right? What will you do? As simple as that. You'll just go ahead, do a maybe write a regex or scan across your code base, replace all these hex values with a new value, right? And boom, everything works. But now imagine change like updating tens or maybe hundreds of these components across projects, right? It's a nightmare. So let's see what happens if we have design tokens here. So I've created a design token named feedback background notice, which means that I need a background, I need a background color for a feedback component, which is of variant notice. And that points to a hex value. Now taking the same example, imagine that we want to change the color of these feedback components, background color. What I'll do is I'll just go and change the value of these tokens. And my consumers, they don't have to do anything. They'll just update the version. They'll get all the updated values. All the projects they work across. As simple as that, right? Now let's see, let's move on to the design tokens in Blade, which is our design system at Razorpay in V1. Like when we started initially, that's why it's called V1. So just to set the context, we have different products that run across different platforms. On web, on mobile app, they have different branding, they have different themes, colors, everything. So now you'd be imagining that this is a very classic use case or a very obvious use case for evolving products at this scale. So which means design system is a no-brainer, right? But how do you prove that design system is worth the investment? Because all of us know that it's a big investment. So how do you justify the effort versus impact equation? So what we did was we decided to build the MVP version of Blade with a pilot project. Now, with a pilot, like what I mean by pilot project is it's basically a project on which we'll use the design system. So what we did was we like back then we were creating a mobile app, and we decided to create design system alongside that. So that become like whatever we are building, that become the immediate consumer of it. So that's why it's like MVP product and MVP a version of our design system. Now let's see what were the tokens that we created back then. So we didn't pay much attention to tokens, but I'll show you in a while like what do I mean by that. So all of us, we just always begin with creating colors, right? Because that's what gives or adds some visuals to your products. So we created as someone would create, we created the color palette. So this color palette, just to show an example, was named as Sapphire. That was just a name, and then we had a scale from 100 to 900, which basically presented different shades of blue. But if you look at it, base color palette is literally not sufficient. Like, what does Sapphire 500 mean? Do I use it on button background, or do I use it on buttons overstate, or do I use it on a background color? So hence, what we did was we introduced one more layer called aliases, which will be an alias to these base color token. Now let me show you with an example. So previously you are using Sapphire 500, right? And that was directly pointing to a hard-coded value. But then we added one more layer, which is primary 500. That kind of added some sense to Sapphire 500, because we'll say, okay, now imagine that if we want to change our primary color to be green, all we have to do is change the internal mapping. Like primary 500 can map to, let's say, emerald 500, which is our green, and then nothing changes on our consumer side. All of us are happy. So that's why we created an alias layer, which was again similar to our base layer. So that had a name of primary, and then again it ranged from 100 to 900. Next, we had a very obvious typography scale. Just pay attention to pixels, like all these values, they pointed to pixel values. Now let's see these tokens in action. So imagine you want to create an OTP component, right? And now let's see what if you were to use the tokens from our system, how would you use it? So you would basically just like, let's say we want to point out to all the blues. What we'll do is, like, all of them are pointing to primary 500. Similarly, for typography, we are pointing all the typography, like all the text, to text dot extra small. Now let's see the actual values or these mappings of the tokens. So we have primary 500, which points to Sapphire 500, and then it points to a hard-coded value. Similarly, tone 930 is pointing to slate, and text extra small is pointing to 12 pixel. Now imagine tomorrow we decide to rebrand ourselves for any reason, right? And we change our all the blues to navy blues or some of that shade. All we have to do is we'll just change the internal mappings. Like primary 500, now instead of pointing to Sapphire, it might point to slate, right? And my text dot extra small might point to 13 pixel instead of 12. Now, on our consumer side, it will just get a refreshed look, right? Without me doing anything or any of the consumers explicitly doing anything. So you might be wondering, right? Everything works. Hooray. Thanks for coming to my talk. That's it. Design tokens, they work. Everything is fine. They work in action. Unless I say that we were so excited that we didn't even think twice and began scaling the system, which was just MVP, right? You never scale MVP systems, but usually that's how the journey happens of any company or any of the products in a startup, right? So let me talk about issues one by one and how did we fix them. So let's start with issues with color tokens, right? Now, what does primary 500 mean? Shall we use it on button? Shall we use it on default or hover or active state? It just means primary, right? But in primary, what is the state of the button? Is it default, hover, active, disabled? Similarly, what is primary 500? Is it only for button? What about radio, checkbox, my text input fields, which have similar requirement, right? Which means the aliases are not semantic. They don't reveal the actual purpose. The next issue was color contrast issues. This was a bigger one. Like most of our text, they weren't even passing AA contrast checks. No naming or guideline to define the structure of the token. Now, what do I mean by that? Now, imagine that you want to add light or dark mode support to our tokens, right? The most obvious way you would think is, okay, now I'll just say primary 500 has a particular state of light, hover dark, and similarly you create a hierarchy, right? But what is the structure? Do you say primary dot 500 dot disable dot light or primary 500 light dot disable? Like both of them might work, but how do you decide a guideline for that? Because this might get complex and you won't even know once you hit the scale, that how to solve what, and everything would be a mess in your entire system. So how did we fix it? So as a first step, we first overhauled our color palette. So now we have two color palettes. One is our chromatic color palette, and then it is our neutral color palette. These were our two categories. Like one is the entire visual like colors, and then you have neutrals, which are nothing but blues and grays. That is mostly used for surface, backgrounds, and everything. Yeah. So this is what would be the reaction, right? Every time we see all these shades, it's like, okay, fine. All right. So what were the outcomes after we did this overhaul? Let me show you. First thing, it just fixed, like we kind of fixed all our text contrast ratios. Like all of them were meeting at least double A benchmark, be it chromatic or be it neutral color palette. Next, our color palettes now have proper depth and cues for which is specifically required for supporting light and dark mode. Now, what do I mean by depth and cues? Let me show you with an example. So this is a famous example from Refactoring UI book. So let's go one by one. So first start with a left version of this is a podcast app. So let's start with a light version. You could see like it's very evident, it's very prominent, right? You could like all the elements which are necessary are emphasized properly. And now usually what people think is that dark mode is just an inversion of light mode, but that's not true. And we can see that in this example. Now look at the second example, right? This is like an inverted version of the light color palette. Now if you look closely, the media player at the bottom has the least emphasis, like it's not being emphasized, right? Similarly, the podcast that is written on the top, that is also not properly emphasized. So that is because we just inverted the color palette, which is not correct. We need a depth for elements which are required to be emphasized. So the third part, which is a color palette which has proper depth and cues, which is meant for dark mode. And now if you could see the first and the last version, they basically signify and they emphasize the similar elements that for users. So now if you look at our color palette, they are not inversion of each other. This is basically blue gray light and blue gray dark. They are not inversion. These are color palettes which are explicitly defined to handle these depth and cues for light and dark modes. Next, we started with the tokens re-architecture, like the whole architecture of our tokens with structures and everything. We decided to redo it. Now let me show you what we did. So first, we added, like it became now a multi-layer token architecture. The first one is the actual value that is now aliased with global token. And then we have two parts, which is either it could be a theme token or it could be a component token. Don't worry, I'll just explain it with an example. Imagine you have a color value, which is the HSL equivalent of this blue color. That's an actual value. Now you have a global token, which is Azure 500. Now these global tokens are not exposed to our consumers because that's not semantic. That's not what is consumable by our consumers. So we create another layer on top of it, which says action primary default, right? Action background primary default. These are our theme tokens. They are exposed to our consumers. Now, if I have to show this in action, this is a button and this is a token that is used to identify the background color of this button. So it says action background primary default. But you would be thinking, Kamlesh, even though you added this layered architecture, how are you solving the problem of naming? You just showed us that how do you name it, right? So again, the same confusion arises, like whether you call it action dot background or primary default or action primary background default, and so on and so forth. So again, it's very confusing, right? Now to clarify this confusion, so we took inspiration from Nathan Curtis, this naming tokens blog post. We decided to follow this structure which says object, base, and modifier. So let's understand what each of these mean. Now we'll start with object. So object in our case is theme, like that's where everything starts, right? That's basically an entry point. Then we have base, which is subcategorized into category, behavior, and property. So category is nothing but the category of the token. Could be color, typography, spacing, border, breakpoint. Similarly, behavior is the behavior of the element. Could be feedback. Feedback could be action, could be your toast, badges, alerts, everything. They are of the feedback category, right? They give some feedback to the user. Similarly, action could be buttons, could be links, etc. And then property is the actual property of that element. Could be your background, could be your text, could be your border, could be your font family, color, anything. Then the third part, modifier. Now that's basically what keeps on modifying. Now that modifier is also subcategorized into following. Could be variant, could be state, could be scale, could be mode. Variant is very obvious, primary, secondary, tertiary, or it could be positive, negative, your neutral, anything. Then what is the state? Let's say primary button, default state, hover state, active state, and so on and so forth. Similarly, for typography, you might have scale, which could have t-shirt sizing, or it could have a scale of 100 to 900 or something like that. And then you have mode, which says light or dark mode. Now, this, like, I'll just keep this slide for like a couple of seconds for all of you to absorb this information, and then I'll take an example to show how this thing works in action. So let's understand this better with an example. Imagine you have these two buttons, primary and secondary. Now I want to say that, hey, give me a color for a primary button in a default state, right? So now if I have to map it to my object-based modifier terminology, I would say my object is a theme. Inside theme, give me color, which is the category of my token. My behavior is action. I want a background, which is my property. And the modifier is primary variant and default state. So that gives me a token, which is how you speak, right? So that's the that's a terminology, and it's literally vocabulary that the way you speak, right? So you say, give me theme dot color dot action dot background dot primary dot default. Similarly, for a secondary button, you would just say, hey, give me a background color for secondary button in a default state. So similar structure, you say theme, then you define base, which is color, which is color, your action, background, and then you say, give me the modifier, which is my variant and my state. So what was the outcome of all these things? Like this architecture is what is something that helped us scale everything. Like it was something that handled all the complex use cases. It also helped us add multi-brand theme support. Like, let me explain you what does this multi-brand theme mean. So just one example, we have two products primarily, payments and banking, as I showed in the beginning. None of them is a dark or light version of the other. They are literally different brands, but they are part of Razorpay. So you could say payments has a light and dark mode, banking has a light and dark mode. But all these things in front of your eyes, you might think, okay, this makes a very minimal difference, or the colors are like, if you observe properly, you would see that there are a lot of color differences. So let me show you a bigger picture. This is how all these things pans out. So payment and banking, they are not dark or light of the other one. They are literally two different brands, but they are part of Razorpay. Now, do you want to see a cherry on the top? So we created this Figma plugin. So whenever you want to change or update any token value, the designer, they'll just update it over here, and then they'll just run this plugin. This plugin just takes up all the token, opens a pull request on our GitHub repository with all the changed values, and all we have to do is just merge it. Everything is in sync, my Figma, my code, and that's exactly what we say. Your design decisions are stored centrally, and then they are reflected on different platforms. You can read upon all this, all the decisions that we took behind this token architecture in our RFC on our repo. This is a short form, like bit.ly/token architecture. To sum it up, now what all we have accessible color palette. All of them are passing at least AA contrast ratio. We have color palette with proper depth and cues, which helps us to support light and dark mode. We have scalable and semantic token structure. Everything is literally semantic. You say and you get it. Extensible to support multi-brand theme, different themes. Like imagine we have another product line that is coming tomorrow, which has like completely different theming with greens or let's say reds. We could just support it. A Figma plugin to keep everything in sync. Next up is let me show you the next issue. So we fixed color tokens issue. Now next issue was with typography. If you remember, I told you hold on with this pixel. So everything was pixel. Now, what was the disadvantage of that? Imagine that you have a browser default font size set to 16 pixel, right? And it says that the text of this primary button is of 14 pixel. Now, since everything is like all the units are absolute units, if you change your browser's font size, nothing would change. It would still be the same, which means people with visual impairments, they would find difficulties in reading the text if they change anything. Similarly, on React Native or let's say native mobile applications, uh, on different devices of different resolution, again the text doesn't scales. It's like on a smaller resolution it might look proper. On a higher resolution device, it will just look smaller. So how did we fix it? So we decided to use each platform's relative units. So that is REMs on web and DPs on native, which is density independent pixels, with auto scale on. So again, you can read upon our RFC about typography units. Again, on the repo and the links typographies hyphen units. Now, what were the outcomes? So, taking the previous example again, now all our the text elements, they have a token, like they point to a token which says, like for example, we say theme like typography font size 75, that points to 14, but that is converted to basically rems, which is nothing but 0.875 rem. Now since it's rem, it's relative. If you change your browser's default font size, it will just scale. So that's basically all our text is now accessible to people even with visual impairments. Similarly, it worked on React Native or our mobile native applications as well. If you have a lower device with a very small resolution and a device with a very high resolution, your text would just adapt to the device's resolution. But how do you store these decisions in a platform agnostic way? Like, how do you say REMs on web and then DPs on native? Like, it's like, how do you store it? Like, I just mentioned that it should be decisions that could be stored centrally, right? So what we did was we decided to store all these tokens with unitless. Like the values of the tokens, if you could see, are unitless. Like it doesn't says 14 pixel, it just says 14. So let's take an example. Now, if I say I want a font size of 400, that will just point to 20. Now, what we do is based on the platform this is being required on, we kind of convert it into either REMs, which is on web, or either DPs, which is on native. That's again an abstraction within our system. So this is basically the gains that we got with relative units. The next one is like again the next issue. So we had the same typography scale on across different devices, either mobile or desktop. Now that's not the ideal case. Like your headers, let's say, like the text might look bigger on smaller devices. Let's say in this case the heading, right? 36 pixel might be good enough for a larger screen, but on a smaller screen it might look just bigger, even though it's a responsive, but it's looking very bigger, right? It's that's not the ideal intent. So how did we fix it? We created two typography scale, one for desktop and one for mobile platform. Now, if you could see, these are like two different scales on the screen. One has a on desktop thing and one has a on mobile thing. So what was the outcome? Now, the outcome was, since we had two different scales, you like all the application, they'll just point to tokens, right? And this is the power of again token. You just say token, what value it resolves, it's is again dependent on the system. So on mobile devices, it was resolving to 32, and then on desktop it was resolving to 36, which again will be converted to REMs. So that handled our typography, accessibility, and all the issues related to the text content. So to sum it up, we use platforms relative unit, that is REM for web and DP for native. We stored token values without units attached. We created two typography scales specifically crafted for desktop as well as mobile devices. Next up, we created breakpoint tokens. Again, this was not present in our previous version, so that helped us define different breakpoints for different devices, so that we can just say, okay, this is a mobile device, this is a desktop device, and we can make all the optimizations and changes or create UIs which are crafted for those specific device screens. Next, we added motion tokens. Now, motion tokens are nothing but they are basically that decisions that drives your animation. Like you would want all your animations to behave consistently, right? You would have like collection of delays, durations, and maybe easing, but it should not just be like different dynamic for every product. It has to be consistent across your product so that it gives like a proper brand experience to your consumers, right? So we stored these decisions even in the form of tokens. Again, there's a RFC written on this on our repo. You could go ahead and just read about all the findings that we did over there. But you would be thinking, right, that all these things, they look good in theory, but they feel very overwhelming. Like imagine I am a consumer of this design system. If I have to think about all these things, about different scales, different color palettes, on like accessibility on different devices, it would be like just too much to expect from our consumers, right? And that's not what the aim of design system is. The aim of design system is to also solve my developer experience, right? So let's say you want to create this card. This card should have your theming capabilities. It should work across different devices. It should have different typography, text content scaling, blah blah blah. Everything that I just spoke about, right? So how will I write a code for this? Let me show you. Just import these two things. One is our provider, which has all the intelligence, and then we have like a proper brand theme. Like we have different. Right now we have two themes. One is payment and one is banking. Imagine right now I want banking, and then I say, and then I wrap my card into this provider. And you know what? This is the exact code that will run on React Native too, without changing anything in the code. Just copy paste this thing, paste it in your React Native application. It will just work. So this is what we get. This is just an exam output. We change themes. You change the light or dark mode, and you will just get the expected behavior. We'll again go to, let's say, banking theme, light mode, banking theme, dark mode. I'll just reset the viewport, and it will again be adaptive, or like it will just scale my typography content. So let's see what all do we have now. First, we have like well-defined token architecture that scales because we follow the terminology of object-based and modifier. Then we have global color tokens, which is Azure 500, which helps us abstract out all like your global tokens are nothing but setting the boundaries. Let's say if theme tokens doesn't work out, what is the boundary that we have set for our design system? Then we have theme tokens. These are tokens that the consumers would say. Again, these are very, very semantic. The way you speak is the way you get the token. Um, then we have responsive typography tokens. Like we use relative units for different platforms so that everything scales based on those based on the internal devices rendering platforms. Then we have multi-platform typography tokens so that you have text intended for mobile as well as large screen users. Then we have breakpoint tokens so that you can identify or define what content to go where and how to optimize experience for each and every device. We had motion tokens so that we can just have good enough animations across our devices, be it web, be it native, and in a very consistent way. So that's all. It's on GitHub. You can go ahead, read upon read upon source code. Everything. A lot of things are going like they are still in work in progress. A lot of decisions are being added daily. But yeah, you can just go ahead, read upon everything, read upon all the RFCs, because like whatever we take big decisions, we kind of try to capture them in our RFCs. That's all from my side. Thank you. You get a design system, I get, and everyone gets a design system. So thank you so much for that.